Okay, section 5.5 has two things it's looking at. It's looking at the degree of a polynomial, and that's the very first thing that we'll do. And then the second part of 5.5 is they'll have you do adding and subtracting different parts of it. And degree of a polynomial basically is this. This is the power, or the highest power, we'll say it this way. So the degree of a polynomial, that's just the highest power. Now, it has to be the highest power on variable. Sometimes they'll put one with a number. Most of the time they don't, but if they were getting sneaky, they might do something like that. So it's just the highest power of a variable in whatever expression they give to you. And all that they're going to do with that one is they're going to say, all right, well, once you find out what the highest power is, the leading coefficient then is the number. The leading coefficient is basically just the coefficient that is in the term that has the highest power. And they don't do a whole lot with it in this section. It's more one of those things that they kind of come back to it later on, especially if you're going on into pre-cal. There's certain things that you do based on what that highest degree is, and it tells you things about how the graph looks and all these different things you can do with it. But now they just have you focus on, okay, what is it? Let's find out what it is. If you can find it now, when you get to pre-cal, they'll go back and dig into it a little bit later if you're working in pre-cal. And we'll just look at some different examples here, and they're going to ask you basically to do both here. Okay, so first objective that you've got in 5.5 is you're just going to find out what the degree and what the leading coefficient are of whatever expression that they give to you. Okay, and the easy part is just find the highest power. Right here, right? We got third power. There we go. So we've got the power of 3, so that's our degree. And the leading coefficient, well, that's just the number that's in front of the variable that you have here. So your leading coefficient would then just be -2. Okay, let's give you one more of those. Okay, so let's go with 6 plus 3x plus 10x to the 4th minus 5x squared. Okay, so again, find your highest power. It's x to the 4th, so your degree is equal to 3. And I'm going to abbreviate just so it doesn't take us quite as long. Your leading coefficient then is just the number that's in front. And that would be 10. Yes, sir. Oh, sorry. I don't know what I'm doing there. I'm looking at something totally... 4. That worked. Yeah, I don't know what I was looking at. I think I was looking at the problem above it and saw that 3. Just copied it down. So, always the highest power. No matter where the highest power is, doesn't matter. Just go find the highest power, whatever that number is, and the number that's in front of the variable, then that's your leading coefficient. Okay, and that's it. That's all you have to do. There's nothing else you do with those numbers. That's just a couple of things that they get here. All right, and then the second and third objectives that you've got to do in 5.5, which are basically the same thing, is they're going to have you add and subtract different expressions together. I don't know where that jump keeps coming from. Try it again. There we go. In most places, they will call this combining like terms. Now, we're going to start adding and subtracting, but before we do that, just remember that we'll kind of back up for just a second. That if you combine like terms, this is where you can add or subtract depending on whatever the signs are. We'll just say add or subtract here. That you can add or subtract the coefficients. Of like terms. Now, and when we talk about like terms, that means it's the same variable with the same power. Okay, so when you're combining like terms, that's the biggest thing, is that when we talk about what a like term is, it has the same variable with the same power. That x squared is not a like term with x to the third because they're both x, but they have different powers. So if you're going to be able to combine, add, or subtract, they have to have the same variable and they have to have the same power. If not, there's nothing you can do to add those two things together. So what you're going to do when you add or subtract the coefficients of the like terms, the one thing you have to remember is that when you add or subtract the coefficients, you do not change the powers. That when you add and subtract, you only worry about the numbers that's in front, the coefficients. The powers don't change. They stay exactly the same. Okay, so just so you got to kind of get the image in your head here, that if you had 4x squared plus 7x squared, 4 plus 7 would be 11. And again, your x squared term doesn't change, it just stays x squared. And if you had 6x plus 3x to the fifth minus 9x to the fifth, the 6x doesn't have what's understood to be the first power. There's no other terms that have the first power on it. So if you try to do anything with that one, there's nothing you can do as far as adding and subtraction goes. It would just stay 6x. The only thing you can do is just put these two together, because they're both x to the fifth, and you'll do 3 minus 9 to make that a negative 6 x to the fifth. So when they talk about adding and subtracting, simplifying different expressions, that's the key thing you have to have, is that before you can do any combinations of adding and subtracting any kind of terms, they have to have the same variable and they have to be with the same power. If any power is at least a little bit different, they stay separate. So you've got x to the first will not combine with x to the fifth. So those two things will stay separate there. Okay, so here's what they'll do. Here's the main part that they'll get into when they go through this one. So I was just kind of backing up for just a minute to make sure everybody's okay with the like terms. Second objective that you've got here, they're just going to tell you to add or subtract. they may tell you to add or subtract the polynomials. And polynomials is just an expression that has two or more parts. This would be a polynomial that's got the plus and minus signs separate all your terms when you think about it that way. So this one would have one that starts off with two terms. If we had, going back to this problem back up here, this has got 1, 2, 3, 4 terms that you would have. If you wanted to back up, this would be a term, this would be another term, that would be another term, and then that would be another term. So when they start talking about combining terms, the pluses and minuses always separate the different terms that you have there. Okay, so here's what they'll do. Look something kind of like this. We'll do a couple of these to make sure that we got it. So this will be like a 2-way. They'll go 2v squared plus 6 plus 3v squared minus 4v plus 5. Okay, and the good thing about addition, there's no trick questions on this one. It is what it is. You just take whatever terms you have. You've got a 2v squared and you've got a 3v squared. So go ahead and do 2 plus 3 and make that 5v squared. You've got a plus 6 and a plus 5. So 6 plus 5 is 11. And you've got the 4v that's here. There's no other v to the first power term, so that one will just stay by itself. It just stays a minus 4v. Now, and you don't have to do this, or they shouldn't ask you to do this in the answer yet, because I don't think they talked about it. Where you put the numbers, it doesn't really matter, but most of the time when you do problems, the way it looks, the way most people like it, is that you want to have it with the highest power term first, and then you go in descending order of powers. So if they talk about writing anything in descending order, then basically you would take the answer you got here and just start off with your highest power v, then you just start counting down. We've got v squared, v the first, and then you would put the constant at the end. So it should be okay either way, but if they get picky about that it's got to be in descending order, then you would go back and put it this way. But most of the time they don't really care. As long as you got all the terms, where you put them, it doesn't matter. As long as the coefficient is correct and the power is correct, everything else should be good. Okay, here's where you got to be a little bit careful. Right, we'll take the same exact problem here, but we're going to make one small change to it. So we'll go 2v squared plus 6 minus 3v squared minus 4v plus 5. Again, that's our change. We're going to put a minus sign in the middle.